The Coriolis effect is a phenomenon that occurs when you launch an object about a rotating axis. For example, when you're throwing a ball across the rotating axis of a merry-go-round, airplanes flying north and south across the Earth, or hurricane movement wind patterns. So, for example, if you're throwing a ball to your friend on the other side of a spinning merry-go-round, you think the ball would just go straight to them, but in actuality, it would appear to turn in midair and not go in a straight line at all. And this is all because of the Coriolis effect. So the explanation behind the Coriolis effect is simpler than it appears. Basically on Earth, angular momentum is higher at the equator than it is at the poles, since angular momentum equals moment of inertia times W. And since moment of inertia is mr squared, at the equator you have a higher radius than you do if you were nearer to the north or south pole. And then due to conservation of momentum, if you initially start at the equator and you fly north, you still have the momentum that you had at the equator. Thus, the Earth appears to be moving slower underneath you, and you therefore gain an eastward trajectory if you try to head straight north. Let's say we had an airplane in Texas and we wanted for it to fly in a completely straight line north to Nebraska. However, if we flew in a completely straight line north, it would not end up in Nebraska due to the Coriolis effect. This is because in Texas, we have a higher radius away from the axis of Earth's rotation than we do in Nebraska. Thus, the airplane in Texas has a higher tangential velocity than it would have in Nebraska and a higher momentum. Due to conservation of momentum, the airplane would not be able to fly north because it still has that eastward momentum from being in the center, and it would end up flying northeast towards Delaware. The Coriolis effect affects the southern hemisphere different from the northern hemisphere. If you try to fly in a straight line from about Venezuela down into the Atlantic Ocean, instead of ending up going right, your plane would actually end up going left. This is because no matter whether it's right or left, since the Earth is moving clockwise, you will always end up going east if you try to travel in a straight line away from the equator. The Coriolis effect also affects hurricanes. Hurricanes are primarily made up of high-pressure areas around the outside of the hurricane with a low-pressure eye in the center. This causes all that high-pressure air to try to rush towards the center to equalize pressure. However, due to the Coriolis effect, at least in the northern hemisphere, all this air is slightly diverted to the right, causing the spinning motion we know that happens in hurricanes. So any fast flying object is going to be affected by the Coriolis effect. This includes planes, rockets, and really anything else that flies. So, for example, if a plane wants to travel from Portland, Oregon to Portland, Maine and they fly in a completely straight line, they'll actually end up somewhere around New York or Pennsylvania due to the Coriolis effect. This is why they have to do a slightly curved route to actually end up in their proper destination. Military aircraft and missiles also have to calculate their flight patterns according to the Coriolis effect. Another application of the Coriolis effect happens in Earth's wind patterns. Towards the poles of the Earth, there is a higher air pressure, and at the equator, there is lower air pressure. This causes wind to rush from the poles to the equator and back. If there was no rotation of the Earth, this would only happen north-south with no east-west deflection. However, due to the rotation of the Earth and the Coriolis effect, wind is deflected eastward as it leaves the equator, due to the equator moving faster, having a faster tangential velocity than closer to the north. This results in the wind patterns that we see today, including east-west facing winds.